Thank you so much for watching our last video on standard deviation. In this video, we will continue our discussion and we will explain the difference between population standard deviation and sample standard deviation. Quickly doing a recap, standard deviation is nothing but summation I is equal to 1 to n, where n is the number of observations in the population, xi minus population mean whole square divided by n, and we are doing a square root of this complete equation or complete fraction. This is a standard deviation, and if we will not do the square root, then this is basically a variance. What this is telling you that on an average, how far our elements are located from our mean, in this case, a population mean. Now there is a slight difference between population mean, population standard deviation, and sample standard deviation. The formula that we have seen just now is for the population standard deviation. But in case of sample standard deviation, there is a slight difference in the formula, and the formula is summation I is equal to 1 to n, where n is the number of observations in sample xi minus x bar whole square, where x bar is basically sample mean, divided by n minus 1, and we are taking the square root of this complete observation. N, as I have already mentioned, is the sample size, and we are subtracting it by n minus 1. So if you will see, there are two major differences between population standard deviation and a sample standard deviation. First one is we are taking a deviation from population mean in case of population standard deviation, while in case of sample standard deviation, we are taking the deviation from sample mean. Second one is, and the major difference is, here we are doing a division with the help of total number of observations in the population, while in this case we are taking a division and basically we are dividing it by the total number of observations minus 1 in the sample. So n is the total number of observations in the sample. Why that is the case? To explain this, first of all, I need to explain you that why we take a deviation from population mean or a sample mean. I'll try to explain this with the help of two different approaches. First one is without using calculus, and second one is with calculus. Starting with the first approach. Suppose we do have a data of 11 students, and this is for our population. That means this is the complete population that we do have. We do have their marks in mathematics. Then we have calculated their mean, which is nothing but summation of all these observations divided by number of observations. Now this is the mean, which is 55.1. First step is we are taking a deviation of xi from their mean, and this is nothing but this value 42, for example, minus 55.1, which is nothing but minus 13.09. So this is the deviation from mean. And in the next step, what we are doing is we are doing a square of these deviations, and this is the square of those deviations. Once we have the square of the deviations, what we need to do is we have to sum over all the deviations and divide it by the total number of observations, and in this case it is 11. That will give you the value of our variance, and the square root of variance is nothing but our standard deviation. It's exactly the same formula that we basically discussed just now, which is summation I is equal to 1 to n xi minus population mean whole square divided by n, and then we are doing a square root to get the standard deviation. Just remember this value, which is called 20.61. This is the standard deviation that we get when we are taking a deviation from mean. Let's take another value, and in this case value is basically any value which is less than mean. For example, let's take the 40 and follow the same steps where we are subtracting 40 from all the observations, which is called deviation from not mean but any observation. And after taking this deviation, we are doing a square of that deviation, which is square of 100, which is coming out to be square of 10, which is coming out to be 100. Then we are adding all those square deviation. Once we have the sum of square deviations, we are dividing it by again the number of observations, and here it's coming out to be 652.36, and square root of variance is our standard deviation, which is 25.54. If you will see, 25.54 is higher than 20.61. That means if you are taking a deviation from any point other than mean, you are getting the higher standard deviation. Similarly, if you will take any value which is greater than mean, and then you will take a deviation and follow the same steps. First of all, take calculating the deviation, then after calculating the deviation, you are squaring the deviation, and once you have squared the deviation, you are summing it up, dividing it by total number of observations. Then that will give you a variance, and square root of variance is our standard deviation. So we have discussed three scenarios. First, when you are taking a deviation from mean, value less than mean, and value greater than mean. In greater than mean, we are getting the deviation or standard deviation of 21.18. When value is less than mean, then you are getting the variation or standard deviation of 25.54. And in case of mean, you are getting the value of 20.61. So if you will see, when you are taking a deviation from mean, standard deviation is lowest. That is the importance of mean in the formula of standard deviation. Basically, what we are doing is, if we are taking a deviation from mean, the average deviation that you will calculate or the standard deviation that you will get will be minimum. Let's prove the same point with the help of calculus. Let's find, first of all, write the formula. Summation I is equal to 1 to n xi minus v whole square divided by n. This is the formula or the major term in the standard deviation. We can ignore or exclude the square root for the timing because it will not have any impact on our calculations. Now, if we will derivate this with respect to v and put it equal to 0, because this is the first order derivative that we need to put to 0 to find the value of v, and once we will find the value of v, we will do a second derivative which should be greater than 0, so that we can say that the value of v that we get is the local minima point. Now let's start with the derivation or derivative of y. This will be summation I is equal to 1 to n. 2 will come down, xi minus v minus 1 using the chain rule, and we will divide it by n, and we will put it equal to 0 because first derivative should be equal to 0. N and 2 will cancel out if we will take it to the right side, so we are left with summation I is equal to 1 to n xi minus v minus 1, which is equal to 0, and this will be summation I is equal to 1 to n xi minus nv minus 1 equal to 0, and this will give you nv is equal to summation I is equal to 1 to n xi, and hence the value of v is xi by n summation I is equal to 1 to n, which is nothing but mean, and in this case population mean. Now we know that first derivative gets 0 when value of v is mean. Second derivative will be nothing but this value dy2 divided by dv2, which is the formula for second derivative. Our first derivative is 2 by n summation I is equal to 1 to n xi minus v minus 1. This is our first derivative. Our second derivative will be again with respect to v, it will be nothing but minus 1 and we are multiplying it with 1, so it will be a positive value. And since our second derivative is positive and first derivative is equal to 0 when v is equal to mean, then we can say that standard deviation is minimum when calculated from mean. We will continue our discussion on why standard deviation is different from a population standard deviation in a second part of this video. In case of any concerns, please feel free to add your questions in the comment section, and please like, share and subscribe. Thank you.